Hey everybody, it's Bob here with Making Stuff, and this is the second video in the horse water trough video. If you haven't seen part one, I'll put the link up here at the bottom of the screen. In the first video we built this water sensor and we left the end open, and I said in part two we would work on this end and get the electronics hooked up. So what I've done is, instead of working with this one from part one, I've got one that I had in service that I had to remove today because the batteries quit working in it. So I just figured I'd pull it out of service and show you guys one that I've been using. It's been running about 10 months. And the batteries finally went dead, but this unit works, and it's the same principle as in part one. Now if you look here on the end, what I've done is I've glued in here one of these watertight cable strain reliefs, and I don't know if you can see on the camera, but you glue or thread one end in, and then you can tighten and loosen this end and move the cable in and out. So what I did is I just took some cable and fastened all the wires to the screws here, and ran that cable out the side. So here is the box that the sensor is connected to, and I've got the same watertight strain relief connectors here. We've got the blue wire goes to the water sensor, then I've got a white wire that it's a coax, and it runs to this 2.4 gigahertz directional antenna. And this, for most purposes, would probably be overkill, but this particular water sensor was on the other side of the farm here, and I needed to get the signal across about maybe 5-6 acre field up here to the house. So now let's take a look inside the box, and the first thing I want to point out is, if you're going to build one of these, you want to use a box that's rated for outdoor use. Now this one here, you can see it's got this black O-ring type gasket that goes all the way around, and this is important because if you put these outside, moisture is going to want to get in and out. So that seal, that's going to save your electronics inside the box, keep the batteries from corroding, getting water or moisture in there. You just be sure and use one that's rated for outdoor use. And here is inside the box. As you can see, there's really not much to this. The schematic for this board, I've got it on the web page at makingstuff.info. Go there and check out. You can see the schematic, but I don't know if you can see this. We just got an XB with the SMA connector on it, and 4 transistors and some terminals. And I put these terminals in here so if I needed to remove this board, I wouldn't have to cut any wires. The coax comes through here, and it screws into the XB. So it's just 5 screws here to get this board out, to get it out and to work on it. The only other thing other than the XB, I don't know if you can see it, but there's a breakout board that the XB is mounted on. You're going to need some type of a breakout board because the pitch on those pins on the XB is 1 millimeter, which is smaller than the standard 2.54 that most of these breadboards have on it. And other than that, there's a little holder here for 3 batteries, and this breakout board that I've got here has a regulator on it, so I don't have to worry about 4.5 volts going into a 3.5 volt XB. And I'll tell you from experience, they're not very tolerant above about 3.5 volts. I've got a pile of these things literally fried from applying too much voltage. And it's been just as simple as having the continuity tester, running it on the board, and the meter I have uses 9 volts to check continuity, and you touch the wrong pin on here and you'll fry it, and there's no getting it back after that. So that takes care of the end at the water sensor. Now what I'm doing here is I've got a little dedicated, a really old notebook computer I leave out here in the shop. You don't have to use a dedicated computer. You can build you something on the other end, like an Arduino with some LEDs to show you the water level. But what I've done, it was simplest for me, and I had some old laptops laying around, and this is the box I hook up to the laptop. It's just USB, and we'll open it up here, and as you can see, nothing fancy. It's just a it's an XB on a little breakout board that hooks up USB, and that's all there is to it. It's also SMA, so I didn't know when I built this if I would need to put an antenna outside with that directional antenna. I do not need an antenna outside. This one here indoors is plenty antenna, and that's pretty much it. That's all that I've got on the inside, and you can get real creative with the inside part. The possibilities there's a lot of different possibilities, which I'm not going to go into, because this just covers this video covers the water sensor itself. Okay, so here's the screen of the notebook, and I've got the XCTU program running here. This is something you can get for free from Digi. Just go to their website and search for the XCTU. This is the older version. I like it a little bit better than the newer one. The newer one does do a lot of things that this one won't do, but this one is more for the technical side. It doesn't have as nice of a GUI, but it's just straightforward. You know, if you're trying to debug something, I think this one is a better program. That's just my personal opinion. But what we've got here, this screen shows I got 3 packets back from the water sensor, and I'm showing this in hex mode. And the packets for this, for the digis and the API mode, they all start with 7E. I'm going by memory here, but I can't remember what these first 2 values are. The 92, that's a value that indicates the packet is sending back the readings of the digital I/O pins. So when you create your application or your software, you want to look for this 92, because the XBs they talk to each other, and they'll send different numbers here. If you look in the data sheet, it's well documented what the numbers are, but coordinators will send join requests and things like that, and you'll get different numbers here. So you pretty much want to ignore, when you're reading your water sensor, the anything other than a 92. And I've got mine set up to send 3 packets, or 3 polls every time it sends. I've noticed sometimes only 2 will make it back from the water sensor. It'll send 3, but the computer will only pick up 2. So just to be on the safe side, I just send it 3 times. It's just the same packet sent 3 times. And after your 92, the next values here, this 13A2004009F, this is the address of the XB that sent the packet, the transmitter. And if you're going to use this with more than one, like I do, you'll need to know those addresses for the XB, so you can distinguish which water trough or sensors sending you that packet. Then the only other thing for this project that you really need to know, and I'm going to jump down here to the last one, is the second to last digit. This is your digital I/O pin value that's coming back. The last one here is just a checksum. The 14 is a checksum, so the 1F is the value that I'm looking at. And I'll put on the web page, I can't remember from the top of my head what each value is, but depending on where the water level is and which pins are high and which pins are low, it'll determine which value you get here sent back to you. And I'll put that on the web page, so check that out. And that's pretty much all you're going to look for if you're doing this water sensor project. That'll get you everything you need to know. You'll know what type of packet that's sent, you'll know the address of the transmitting XB, and you'll know the value of the pins. It's a combined value, so each pin has a value, and then it's the sum of the pins that are high, I believe, or it could be low. I'm not sure. I'll have to go back and look at my notes, but like I said, this will get you pretty much everything you need to know. And I'll just give you a quick glance here. The program I've got is a C# program that I wrote, and let's get it started here. What it does is it will show you here. It shows me the we got an error here. Oh, it's because I don't have the receiving XB plugged in, so it couldn't read the COM port. But I've just got a little C# program here that has a little like bar graph that shows me the water level, and I also added the last time that we got a read, because if your batteries go dead and you let this thing run for 3 days and it's at 3/4 or a half, and you think you got that much water in your trough, if you haven't gotten a reading in 3 days, you know something's up, like the batteries are dead or something has malfunctioned, and that's a good indicator that you need to go check it, so that you're not relying on the value here thinking that the value is accurate when it may not be. But without that last read, you really don't know if the reading's accurate or not. And with it being outside, there's a lot of things that can go wrong. I've had the horses pull the sensor out, batteries going dead. We've had a tree limb fall on it, all sorts of things. When you put stuff outside, you get a lot of more options for failure. And on mine, they're monitoring horse troughs, and horses don't drink all that much water when you're monitoring 150 and 300 gallon troughs. So mine, I've got it set up to read the troughs every 3 hours, and that's plenty. I find that the value changes. Maybe in the summer in July it might change. It might fall 2 levels in about a 15 to 20 hour period. When it's really, really hot and it hasn't rained in a while, they'll drink 150 gallons in 2 days. So that's the water trough sensor and the software. I've got a lot more documented. Go to makingstuff.info. That's makingstuff.info, not .com. makingstuff.info. I've got part 2 with all of the packets and things on there, and be sure and check it out. And thanks for watching.